Putting together what we've found so far about parallel vectors and the ijk phenomenon, we can try to figure out how to find a cross product in another method. So let's suppose we have a vector u that is u1i plus u2j plus u3k. In other words, it's just three numbers multiplied by their respective component vectors, right? I, j, k. And then same thing with v1i plus v2j plus v3k, right? Now, let's figure this out with distributing. So if I take the u1 piece and I just multiply it by each of those three, so I'm going to take u1i crossed with, and you'll notice, by the way, we start dropping a lot of times the hats on the i's just because it gets annoying. But if you want to put them in, that's fine. So u1i crossed with v1i, that would be the first piece, plus, and then I would take u1i crossed with v2j, plus, and then u1i crossed with v3. So u1i crossed with v3k. So I'm just taking u1i times each of those three. The distributive property still works even if the commutative property not so much. All right, now I got to take the middle one. So I'm going to take the u2j's. I'm going to multiply by each of those three. So I'm going to say plus u2j crossed with v1i, and then u2j crossed with v2j, plus u2j crossed with v3k. And then I'll take my last one, the u3k part. So plus u3k crossed with v1i plus u3k crossed with v2j. We're just trying to come up with another way to find, well, actually any way really, to find the cross product. We don't have a way to do it yet. So u3k crossed with v3k. Now, remember, parallel vectors have a cross product that is 0. So recall, if u is parallel to v, then u cross v is equal to 0 vector. Now, why is that useful for us? Well, the I vector is parallel to itself, so that is the 0 vector. Similarly, the j vector is parallel to itself, so that's the 0 vector. And then the k is parallel to itself, so that's also the 0 vector. Okay, so now let's combine together a few other things here. So we know that I crossed with j, right, these two, I crossed with j leads to k, right? So these two right here, it's going to be u1 v2 k. So u1 v2 times the k vector. All right, similarly, I crossed with k leads to the negative j vector. So I crossed with k, so plus, and then it'll be u1 v3 times the negative j vector. All right, then what about the orange ones? J crossed with I leads to negative k, so that's plus, let's see, u2 v1, right? J crossed with I leads to the negative k vector, so that's negative k. And then, let's think, u2 v3, j crossed with k leads to I, so that's plus u2 v3 times the I vector. Oh, I have to see if I can fit the last two in. Then plus u3 v1, and that's k crossed with I. K crossed with I is the j vector. And then last one, U3V2, right here, U3V2, U3V2, and then K crossed with J will lead to the negative I vector. All right, so now I can combine together the things that are alike. So for example, let's put the two I ones together. So this one, oh, not this one and this one, those will go together and we can make it equal to U2V3 minus, because there's a negative I on that, U3V2 all times I. Plus, now let's take the two J ones. So it's going to be U3V1 minus U1V3 all times J plus, and then last one K. So we'll start with the U1V2. So U1V2 minus, so there's a negative K here, U2V1. K. And that is what U cross V is. That is how to find a cross product. Now, if you're thinking, oh my goodness, I will never remember all of those little combinations, you'd be surprised. I mean, so for example, I don't know if you noticed, but these are the same things. It's U2V3 minus U3V2. So they're using the numbers that are not I. I is the first eigenvector. Oop, hold on. So as I was saying, the first eigenvector, I, uses numbers 2 and 3 minus 3 and 2. And then J, which is the second one, uses 3 and 1 minus 1 and 3. So that one's the backwards one. And then the third one, K, uses 1 and 2 and 2 and 1. So there's a pattern to them that you could memorize. But you don't have to, because there's another way to do this, an alternative method, because this is kind of annoying on a regular basis, and that is to find the determinant of the matrix. Okay, so the way to find a determinant of a matrix is, and that's what the absolute value is, right? So it looks like absolute value symbols. That's actually matrix notation. By putting big vertical bars like that, you're saying you want the determinant of that matrix. And what you do is you change your vectors, if you will, into a matrix. You have I, J, K right there. You have your U vector right here. See your U vector? And you have your V vector right here, and you have your component vectors up there. Okay, and then it's kind of easier if you just throw another I and J. Under I goes U1 and V1, and under J goes U2 and V2. So if you do that, then you can do a kind of, well, there's a pattern to it. So let me show you. So you work your way down the diagonals. So I gets times 2 U2 and V3 times I, plus, then you do the next diagonal. J gets multiplied by U3 and V1, and then K gets U1 and V2. And then you go backwards. So then you go from the diagonal down, and then these ones will all be negative. So the orange ones will all be positive, because they start at the top. Positive, positive, positive. I don't know why there's a 1 in there, but they're all positive. These ones will all be negative. So I'm going to go this way, and this way, and this way. There's 3 diagonals. So start with the first one, V1, U2. So minus, right, because they're negative, V1, U2 times K. And then minus V2, U3 times I, minus V2, U3 times I, V3, U1 times j. Simple as that. So combining together like terms, if I put the two I ones together, that'd be u2v3 minus v2u3, looking familiar hopefully, I. Now putting together the two j ones, here I'll put them in purple, j and j, that'd be u3v1 minus u1v3 j, or v3u1, whichever. And then last but not least, the two k ones, u1v2 minus u2v1 k. This is bugging me. I'm going to reverse this one. So I'm going to make that minus u3v2. There. Now if that's looking familiar to you, oh, you'd be right, because it's exactly the same as what we just came up with on the previous page. Let me see if I can find a way to show them both to you. There they are. So this one was the one we found using the longhand method, and this is the one we found with that little matrix thing. And they both work. Right? They're going to give you the exact same answer. So you could memorize it, or you could learn how to do that pattern thing with the I, the J's, and the K's, right? So by forming the little matrix box and then building it out and then doing the loop-de-loops. Either way is going to work. It's just a question of which method you find easier for finding the cross product. Now if you're thinking, will Maple find the cross product? Oh yes, Maple will. It's a command called cross product, funnily enough. So that will not be difficult at all to do in Maple if you so desire. But this is how to do it by hand. So let's practice it real quickly. So I'm going to have an I, a J, and a K. Make my box. A for me is 2, 1, 5. B is 3, 0, -2. Close your box, and then add in 2 more rows, or 2 more columns, I should say. I and J, 2, 3, 1, 0. It helps if you keep all the spacing nice and even. Okay, so you go on the diagonal. So you're going to go -2i. I'm just going to put it down here. -2, right? Because that's what 1 times -2 is. So -2i, 15j, and 0k. So that's that first bit. Oh, and I'm finding A crossed with B. That's what I'm looking for here. So that would be that piece minus, because the whole back half gets subtracted, right, since all of them are negative. So it'll be 3k, 0i, 4j. All right, so putting things together, -2 and 0 makes -2i. 15j minus a -4 is +4, so that'd be 19j. And then 0k and -3 makes -3k. So this is the correct vector. If you want to put it in the bracket notation, it'd be -2, 19, -3. So this is with its component pieces, its component vectors, I, j, and k, and this is written in bracket notation. So it looked a lot scarier than it really was. When you first learn it, it seems like it's so complicated, but when you do it with actual numbers, finding a cross product is not actually that difficult.